Hi, I'm Drew Moyer, and this is how to teach rational expressions. Let's take a look at our problem. We have 2 over x minus x over 8 equals 3/4. The first thing I want to do, since I need to add and subtract these fractions, I need to make sure that they're all of the same denominator. So I look at my denominators. I have x, 8, and 4, and I know that the common denominator must be 8x. So I want to multiply all the terms, top and bottom, until that the denominator is equal to 8x. So I have 2 over x, and what do I need to multiply that by to make the denominator 8x? Well, it's missing an 8, but I need to multiply it by a form of 1 so I don't change it. So I multiply the whole thing by 8 over 8. Next term is x over 8. And if my LCD is 8x, I know that this is missing an x. So I want to multiply this by x over x. And for the 3/4, I need to make it 8x, so I know that it's missing 2x. So I will multiply that by 2x over 2x. And then I just want to carry out the multiplication. I have 2 times 8 is 16 over 8x minus x squared over 8x. And up top here I have 6x over 8x. And now, since everything is over 8x, I can then turn around and multiply everything by 8x to get it to cancel out. So I multiply this whole side by 8x and this whole side by 8x. And it will result in no fractions. So I have 16 minus x squared equals 6x. And now, from here, it's just solving a simple quadratic. So I'm going to move everything over to the left side. Negative x squared minus 6x plus 16 is equal to 0. I'm going to multiply everything by -1 so that I don't lead with a negative. X squared plus 6x minus 16 is equal to 0. And then factor this trinomial into 2 binomials. So on this side I would have x, and I need 2 factors of 16. It looks like it's going to be 8 and 2, and the 8 needs to be positive. So this factors into x plus 8, x minus 2. And then because of zero product property, I know that either x plus 8 must equal 0, or x minus 2 is equal to 0. Solve this and I get x is equal to -8. And I solve this and I get x is equal to 2. So I have 2 different answers for this quadratic. So I'm Drew Moyer, and that is how to teach rational expressions.